you on Curiosity Stream.
I'm James Burke. I'm going to take you on a journey through time.
James Burke's visionary series returns, reimagined for our time.
Now, this is all uncharted territory.
The Washington Post hails Burke as one of the most intriguing minds in the Western world. The New York Times raves he careens from one great moment in history to another.
Where do we want to go from here?
Experience all new connections.
So what's the next connection?
With monthly, annual, and bundled plans, find the one that works for you at curiositystream.com.
Hello, Saver. Whether you're saving for that trip to the tropics or saving for an emergency, now is the time to take advantage of Wells Fargo's savings options. Wells Fargo offers savings accounts that can help you save towards your goals. So, what are you saving for? Visit a Wells Fargo branch or wellsfargo.com/save to open a savings account today.
Wells Fargo Bank, N.A., member FDIC.
This is SpaceTime, Series 23, Episode 136, for broadcast on the 18th of December 2020. Coming up on SpaceTime, South America experiences a total eclipse of the sun. The International Space Station gets a new airlock. And Chuck Yeager, the first man to break the sound barrier, passes away aged 97. All that and more coming up on SpaceTime.
Welcome to Space Time with Stuart Gary.
The good citizenry of Chile and Argentina have experienced a total solar eclipse. The December 14th spectacular also provided a partial eclipse in Bolivia, Brazil, Ecuador, Paraguay, Peru, Uruguay, and parts of Antarctica. Solar eclipses happen when the moon's orbit lines up so that it passes directly between the Earth and the Sun. Now, you think that would be all the time, but it's actually not. That's because the moon's orbit around the Earth is actually inclined by 5 degrees compared to Earth's orbit around the Sun. So, normally, the moon's orbit appears to cross the sky either slightly above or slightly below the path of the Sun. But thanks to the wonders of orbital mechanics, roughly once every 18 months or so, the lunar orbit does place the moon directly between the Sun and the Earth, resulting in a solar eclipse. Eclipses happen because although the moon's 400 times smaller than the Sun, it's also 400 times closer to the Earth, so the two appear to be about the same size in the sky as seen from Earth. So, when the Sun, the Moon, and the Earth all line up exactly, the Earth experiences a total solar eclipse. As this occurs, the Moon begins to slowly pass in front of the Sun, and a partial lunar shadow called a penumbra crosses the surface of the Earth. And this can last over an hour as more and more of the Sun becomes hidden by the face of the Moon. Then, just before totality occurs, the crescent Sun converges into a single brilliant white diamond of sunlight, as the very last bit of the Sun's bright disk shines along the edge of the Moon and the first glimpses of the faint corona, Sun's atmosphere, create a ring around the Moon, an effect known as the diamond ring. In the last fleeting moments before totality, the diamond ring breaks up into a string of beads, created as the Sun's rays shine through the low-lying valleys between the mountains along the limb or edge of the Moon. Once this effect, known as Bailey's beads, ends, the Moon has completely covered the entire disk of the Sun, and you're in totality. During totality, the darkest part of the Moon's shadow, the umbra, crosses the Earth's surface. Those lucky enough to be along the path of totality will view a total solar eclipse, and this can last up to 7 minutes and 31 seconds, but they're usually far shorter than that. During this period, the skies go dark, stars will appear, and it suddenly gets noticeably cooler. Birds will start roosting, shadows will take on an unusual crescent shape, and you'll be able to see that tenuous outer atmosphere of the corona glowing milky white. Often explosions on the Sun's surface, called prominences, will appear as spectacular pink or red clouds stretching above the lunar limb. The path of totality can be up to 272 kilometres wide, although usually it's a lot less, and the further away you are from the centre of that path, the shorter the eclipse duration will be. Now, if you're outside this line of totality, to the north or south of it, you'll only see a partial eclipse, in which only part of the Sun's disk will be covered by the Moon. The reason each total eclipse is only visible over a small part of the Earth's surface is because the moon's shadow is relatively small when it falls on the Earth. On average, the moon orbits the Earth at a distance of 374,400 kilometres. But the thing is, like the Earth's orbit around the Sun, the moon's orbit around the Earth isn't a perfect circle. It's slightly elliptical, meaning one part of the orbit will be a bit closer to the Earth. That can be as close as 357,000 kilometres at perigee. And another part of the orbit will be a bit further away from the Earth, around 406,000 kilometres apogee. And when the moon's orbit takes it a bit further away, the moon looks a bit smaller in the sky. And if that coincides with a solar eclipse, that smallness means that the moon doesn't cover the entire face of the sun. So instead of a total solar eclipse, the moon's passage across the sun creates an annulus, a ring of fire, as light from the sun surrounds the dark moon, resulting in an annular eclipse. Most solar eclipses are accompanied by a lunar eclipse, occurring either 2 weeks earlier or 2 weeks later. So lunar and solar eclipses occur with equal frequency, but lunar eclipses are seen over a far wider area because the Earth's shadow is far larger and so covers far more of the lunar surface. A total lunar eclipse occurs during full moon when the Sun, Earth and Moon all align. During this event, the moon passes completely through the Earth's dark shadow or umbra. And even though the Earth completely blocks out the sunlight from directly reaching the surface of the moon is still visible during a total lunar eclipse. You'll see the moon will gradually get darker and then take on a rusty or blood red colour as light from the sun refracts through Earth's atmosphere and undergoes what's called Rayleigh scattering, leaving only the longer red wavelengths, as all the Earth's sunsets and sunrises happen at once to indirectly reflect on the lunar surface. A total lunar eclipse can also look yellow, orange or even brown in colour, depending on how different types of dust particles and clouds in Earth's atmosphere allow different wavelengths of light to reach the lunar surface. A partial lunar eclipse happens when only part of the moon's surface is obscured by Earth's umbra, while a penumbral lunar eclipse occurs when the moon travels through the faint penumbral or outer portion of Earth's shadow. This is SpaceTime. Still to come, the International Space Station gets a new airlock. And how do they get those stunning images of the Earth seen from space? All that and more still to come on SpaceTime. A new airlock has arrived aboard the International Space Station. The equipment was flown up on a SpaceX Dragon spacecraft on the latest supply mission to the orbiting outpost. The mission was also the first flight for the new upgraded Cargo Dragon 2 capsule, which is based on the same design as the Crew Dragon 2. It was also the first time that 2 Dragon 2 capsules were docked to the space station at the same time. The spectacle was the culmination of the launch of the CRS-21 supply mission aboard a Falcon 9 rocket from Pad 39A at NASA's Kennedy Space Center in Florida. The Dragon docked automatically on the zenith port of the orbiting outpost's Harmony module, just meters away from the Crew Dragon 2 Crew 1 spacecraft, which docked on the Harmony's forward port last month. This cargo mission is carrying 2,900 kilograms of supplies and scientific equipment, including the NanoRacks Bishop airlock. This movable bell-shaped structure will be used to launch small satellites, recover external orbital replacement units, allow robotic movements and transfer of larger packages, and provide an external mounting point for payloads and scientific equipment. It alleviates the need to rely on the overused Japanese Kibo airlock, which has become somewhat of a bottleneck for scientific research because of its high demand. The new airlock's also a lot bigger, with 5 times the capacity of its Japanese counterpart. Also included in the scientific payload aboard Dragon is an experiment using microbes to biomine meteorite samples. Research into how changes in the workload and shape of the human heart due to microgravity could become permanent if a person lives in space for more than a year. Also aboard is a new study to look at the ability of a commercially available device to provide quick and accurate counts of total and differentiated white blood cells in microgravity. There's a materials science experiment looking at brazing alloys in space, which would be useful for space construction or repair work. And there's a study looking at the effects of microgravity on human brain organoids. The CRS-21 Dragon will remain docked to the space station for a month before returning to Earth with completed experiments and equipment. This latest Dragon cargo mission to the space station also took on a bit of an Australian flavour, with Golden Wattle seeds included in the payload. It's all part of the Japan Aerospace Exploration Agency project called Asian Herbs in Space, which is designed to see how exposure to microgravity and above-average radiation levels affect different types of seeds. The seeds were originally collected by the CSIRO from a wild population in Victoria. They'll spend 6 months aboard the International Space Station before returning to Earth aboard SpaceX's CRS-22 mission. At this stage, that's slated for May. They'll then be distributed to participating schools around Australia, where they'll be planted and compared to a control group of seeds in order to determine if there's any difference between the two groups. Now, this isn't the first time golden wattles left Earth. Back in May 2008, NASA astronauts took golden wattle seeds to the space station aboard the shuttle Discovery. Those seeds also spent 6 months on station before returning to Earth and eventually being planted in Sydney's Royal Botanic Gardens in June 2014. To find out more, Andrew Dunkley is speaking with astronomer Professor Fred Watson.
Sending wattle seeds into space. Now, this has got a bit of a local spin on it, this story, but the Giant Leap, the One Giant Leap Australia Foundation has arranged all of this, and a bunch of schools, about 150 of them in Australia, will be sending wattle seeds into space as an experiment. Wattle is a plant that flowers every August in Australia, early spring. Beautiful native plant. It's a part of the acacia variety of trees, and they have the flower is like a little yellow bauble. And they grow them in these massive clusters. And if you're having a good season, all you can see is yellow from. I was going to say something I can't say. From one end of the street to the other, they are just extraordinary trees, quite beautiful, but they're very short-lived, as it turns out, Fred. But one of their great benefits is that they are very good at enriching the soil with nitrogen, I'm told, which is
that's true.
Which is a great benefit. But this is a terrific story, and one of the schools involved is the Central West Leadership Academy. I work just around the corner from that school. When I'm in my other job, and this is a big collaboration. A lot of agencies involved in this one.
Including the Australian Space Agency, that's right.
Yeah.
It's great. So the idea is to send these seeds up to the International Space Station, and it's actually a collaboration with the Japanese Space Agency as well, JAXA. That the seeds will basically sit in space for 6 months, then come back to Australia in time for next year's Science Week, which is in August. And basically what the schools will get is wattle seeds that have flown and wattles that are in space and wattle seeds that haven't. And the idea is to germinate them and see how they grow and record the data. And I love the catchphrase there, what'll happen to the wattle? Oh, it's lovely.
I've never heard that one before, Fred.
Sheer poetry.
Yes. But it'll be interesting because I think they've done similar experiments with other life, garden life forms before, and there has been significant differences in their growth patterns.
Yes, that's right.
So it'll be fascinating to see what happens to a native Australian plant. And it'll be very exciting for the students. We never got to do this kind of thing when I was at school.
Absolutely.
I think the most I ever got to do was keep silkworms and cut open a dead mouse. That was about it.
Right. Good thing it was dead.
Yeah, it was very dead, and I put it back together afterwards too. I thought that was the right thing to do.
For the next person.
Yeah, exactly. And the scalpel was blunt. It was a terrible job.
Oh, dear.
Horrible job.
Awful.
Yes. But
that's why I did physics rather than biology.
But, I think being able to get sort of involved in sending something into space, it would be a talking point for years to come for these students. And who knows what their kids will probably do in decades to come. I envisage the day that there might be an excursion to a space station. Who knows?
Yes, it's all possible.
That's Dr. Fred Watson, an astronomer with the Department of Science, speaking with Andrew Dunkley on Space Nuts. And this is SpaceTime. Still to come, how do they get those stunning images of Earth seen from space? And the first man to break the sound barrier, Chuck Yeager, passes away aged 97. All that and more still to come on SpaceTime.
Hello, Saver. Whether you're saving for that trip to the tropics or saving for an emergency, now is the time to take advantage of Wells Fargo's savings options. Wells Fargo offers savings accounts that can help you save towards your goals. So, what are you saving for? Visit a Wells Fargo branch or wellsfargo.com/save to open a savings account today.
Wells Fargo Bank, N.A., member FDIC.
Every week in our SpaceTime Tumblr blog, we show stunning images of the Earth taken from orbit. Some are taken by Earth observation satellites, but many are taken by crew aboard the International Space Station. From their perch some 400 kilometers above the planet's surface, space station crew have taken a mixture of random and carefully choreographed images which are telling the story of planet Earth over the past 20 years. And like the directors of any film, these astronaut storytellers have a crew working behind the scenes to help them tell that story. NASA's Earth Science and Remote Sensing Unit guide the astronauts as they observe and document changes on Earth. Then make those photographs available to scientists and the general public. This report from NASA TV's Michael Karlovich.
From their perch on the International Space Station, astronauts have spent 2 decades sharing a story about Earth as they see it from above. Like the directors of any film, those astronaut storytellers have a cast and crew working behind the scenes to help them tell that story.
The Earth Science and Remote Sensing Group, the ESRS, here at Johnson Space Center, is primarily designed to support the International Space Station program. Our job there is twofold. One, it's to manage the Crew Earth Observations facility on the ISS. That's the handheld crew imagery of the Earth. The other is to serve as subject matter experts to the ISS program for matters of remote sensing.
Though the photos shot from the space station can be quite beautiful, they're mostly shot for practical reasons. Astronaut photography is a science product designed to help everyone from academic and government researchers to resource managers and conservation groups to educators and students. The photographs document changes in our cities and remote ecosystems, in polluted waters and pristine landscapes. They have been used to study everything from urban development and economics to unusual electrical discharges in the atmosphere. These snapshots have been used to observe fishing boats and coral reefs, calving icebergs, and vast inland deltas. Though handheld cameras are not as precise as robotic imagers, they provide a nice complement. Most satellites view the world at the same time and same resolution with each pass. But each space station orbit brings different viewing angles, different times of day, and different lighting.
We've had a number of external science requests for nighttime imagery of various cities for investigators who are looking at light pollution and seeing how that's affecting biodiversity in their cities.
The Earth Science and Remote Sensing team manages dozens of requests for images, with new ones coming in weekly.
We've got this long list of maybe 50 to 100 on any given day that we'll parse through, and the way we decide which target we will ask for the next day is we'll see where the ISS is. We'll take into account lighting conditions, whether it's light enough for daytime targets or dark enough for nighttime targets.
Once we have what they can see, then we'll filter that for predicted weather, cloud cover for that area. There's no point in asking them for a target if they're not going to be able to see it.
With a new sunrise and sunset every 90 minutes, the astronauts have 16 chances to see what the planet and its people are doing. But life on the space station brings its own sort of sunrise and sunset.
Flight surgeons say, do not ask for anything during their sleep period, which is a third of the day. That's a full 8 hours. But you may ask for everything between 6 o'clock and 21:30 in the evening, which includes their getting up time, breakfast time, and the work day, and bedtime, supper time, brush your teeth time.
Having considered astronaut schedules and the viability of each target, the Earth observations team chooses a few targets for each day. They assemble guides and maps so the astronauts can quickly orient themselves. They send the target plans to payload operations at Marshall Space Flight Center, where photo ops are reviewed, approved, and added to the ISS workday.
They will provide for us useful information to help give us maybe cues off the surface of the Earth that will help train our eye to go find a specific target that otherwise would be very difficult to find. And they want that target for specific reasons. Pre-flight, they will have trained us in that and why those elements of that data are so important, which helps us in the technique that we might apply in getting the photograph.
Perhaps the hardest part of the job for the Earth observations team comes after the astronauts put down the camera. Anywhere from 100 to 10,000 images are sent down to ground control every day.
Once that gets downlinked, it gets ingested into our system, and I'll look through those and see if they're appropriate to send to the researchers.
Though computers are now part of the process, for most of the past 20 years, those photos have been sorted by human hands and eyes.
That's the highest priority for us to catalog them. And by cataloging, I mean adding descriptive metadata to the image. Things like what geographic features can you see in this image? That helps. Then when it's fed into our online database, that's what enables people to search for those images.
Every photo has some basic information about the location. But since the ground team did not shoot the photos, they have to decipher what can be seen in them. It is a monumentally important but monumentally time-consuming job.
Because these images are taken by the astronauts, they're looking out at the cupola with a handheld camera. They can look in any direction they want. We know exactly where the space station was when they took the picture, so we kind of have a general idea of where it could possibly be. We know what hemisphere it is in, for instance, but we don't necessarily know which way they were looking.
It is a rich, decades-long catalog of the dynamic changes, forces, and beauties of our planet.
It always struck me how little the remote sensing community used this data. And primarily that was because it historically has been a difficult data set to use. One of the focuses that I've had leading this group has been, okay, we need to bring new tools to bear to make this data set more useful.
Stefanov's team has been working to automate more of its tasks, using new software and computing techniques like machine learning.
If we have a machine that can identify these features automatically, then our database becomes then much more searchable and the public can use it more easily. Scientists can find exactly what they're looking for.
Lambert and colleagues are now training computers to detect and recognize certain features on the land, in the sky, and on the ocean. They're using neural networks to help machines quickly identify photos with a lake or a sea, the limb of the Earth or the moon, a crater or a city. They're particularly focused on clouds.
One problem that people have that are doing GIS is that you've got our imagery, and it's great, but it's got clouds in it. And those clouds obscure what you're interested in looking at. If we have an algorithm that produces a mask where every pixel is labeled as either clouds or no clouds, that label can be applied to the whole image, and they can subtract the clouds from their analysis so that way they are ignored.
Astronaut photographs have been used for some scientific studies and for inspiring people to better appreciate the planet. But the Earth observations team believes those photos could have even wider use, and they want to make sure the world sees more of them.
And in that report from NASA TV's Michael Karlovich, we also heard from Crew Earth Observations Principal Investigator Will Stefanov, Crew Earth Observations Payload Operator Andrea Meadow, International Space Station Mission Operations Earth Scientist Justin Wilkinson, astronaut Jeff Williams, and Crew Earth Observations Data Scientist Mark Lambert. This is Space Time. Still to come, Chuck Yeager, the first man to break the sound barrier, passes away aged 97. And later in the science report, Australia's threatened native plant species suffering a catastrophic 70% decline in population numbers. All that and more still to come on Space Time.
Wells Fargo presents one of the surest ways to grow your money. A Wells Fargo CD account. where you can earn a 5.00% annual percentage yield on an 11-month term with a minimum opening deposit of $5,000. Visit a Wells Fargo branch or wellsfargo.com/CD rates to open a CD account and start growing your savings with us.
Wells Fargo Bank, N.A., member FDIC.
The first man to break the sound barrier, Chuck Yeager, has passed away aged 97. The retired U.S. Air Force Brigadier General was the quintessential fighter ace and a record-setting test pilot, always willing to push the envelope. Yeager made history on October the 14th, 1947, when he became the first person to break the sound barrier in level flight, piloting the bright orange bullet-shaped Bell X-1 experimental rocket plane, Glamorous Glennis.
Cracking the sound barrier in the X-1 marked another milestone in aviation history. The time, October 14th, 1947. The place, Air Force Flight Test Center at Muroc, California. The pilot, Captain Chuck Yeager. The X-1 holds 5,020 pounds of fuel, nearly 1/2 of its total weight when launched. The delicate process of fueling takes 1 hour. The rocket engine propellant is made up of liquid oxygen and water alcohol, the latter being pressurized by gaseous nitrogen. Great caution must be exercised during the fueling operation, since the fuel system in the X-1 has an explosive potential equal to that of its own weight in TNT. A special electrical igniter is used in the combustion chambers to fire the rocket. With all 4 rocket tubes firing, the X-1 will produce a thrust of 6,000 pounds. The engine occupies a space 19 inches in diameter by 56 inches long and weighs but 210 pounds.
All previous attempts had ended in failure, and there'd been multiple fatalities, resulting in many believing the barrier simply couldn't be broken. The problem was shock waves generated by aircraft as they neared the sound barrier, making them uncontrollable. The British discovered the key to pushing through was using far larger control surfaces, information they shared with their American cousins. And after appropriate modifications, the Bell X-1 was loaded into the bomb bay of a B-29 aircraft at the Muroc Army Airfield, nowadays known as the Edwards Air Force Base.
A special pit has been constructed into which the X-1 is lowered for loading into the B-29 mothership. This bomber has been specially modified for aerial launchings due to close clearances. The loading procedure takes a considerable amount of time.
And the big 4-engine World War II bomber took off down the runway.
A climb must be made to 30,000 feet to reach drop altitude. While the B-29 with the X-1 ascends to altitude, radar goes to work tracking the mission. The aircraft flight data will be telemetered to the ground crew throughout the flight. The B-29 has now reached drop altitude. The time for release is drawing near. For high-altitude flight, Captain Yeager wears an emergency pressure chute as he enters the cockpit of the X-1. A manually operated elevator provides safe access for the pilot before the drop. With the checkout of the launching procedure completed between Captain Yeager and the crew of the B-29, synchronized timing begins. 5, 4, 3, 2, 1, drop.
The X-1 was drop-launched over the Rogers Dry Lake bed in the Mojave Desert. Yeager ignited his rocket engine and quickly accelerated the aircraft right through the sound barrier under full pilot control.
With all 4 rockets firing, Yeager climbs to 56,000 feet in less than 2 minutes. And he does it, the first human to crack the sound barrier.
Eventually reaching Mach 1.06, some 1,100 kilometers an hour, 610 knots, or 700 miles an hour.
Now, with propellant exhausted, Yeager reduces his speed and altitude to come in for a dead stick landing at 160 miles per hour. At this hot landing speed, The X-1 rolls for more than 2.5 miles.
The flight was made all the more difficult because Yeager had broken 2 of his ribs in a horse riding accident 2 nights earlier and kept the injury a secret from the Air Force, fearing he could be removed from the mission. On the day of the flight, Yeager was in such pain he couldn't even seal the X-1's hatch by himself. Luckily, fellow test pilot Jack Ridley, who knew about the injury, rigged up a special device using the end of a broom handle as an extra lever to allow Yeager to seal the hatch, a scene portrayed for posterity in the movie The Right Stuff.
And one of the Air Force's best-known flight test pilots has just set the pace for further research in upper air investigation. This flight marks the first milestone in the supersonic chapter in the history of aviation.
This is SpaceTime. And time now to take a brief look at some of the other stories making news in science this week with a science report. A new study has revealed that Australia's threatened native plant species have suffered a catastrophic 70% decline in population numbers over the past 2 decades. The findings by the Australian Threatened Species Index combines monitoring data for 112 threatened plant species from almost 600 sites across the nation. The study of some 1,342 threatened plant species in Australia paints a worrying picture, with different plant types, including trees, shrubs, herbs and orchids, all declining by 65 to 75% on average. The authors found that plant populations in managed sites suffered declines of less than 60% on average, but the declines in unmanaged sites were substantially higher, at around 80%. A new study has found that restricting meat consumption and increasing plant-based protein intake provides greater cardiovascular benefits than a traditional Mediterranean-based diet. A Mediterranean diet has already been proven to reduce cardiometabolic risk and prevent cardiovascular diseases better than a low-fat diet. The findings, reported in the journal Heart, are based on a study of 294 sedentary and moderately obese people with an average age of 51 who were randomly split into one of 3 dietary groups. The first group were told to simply increase physical activity and they were given a healthy diet. The second group received the same physical activity advice as well as a traditional Mediterranean diet. That's one low in simple carbohydrates, rich in vegetables, fruits and nuts, and with poultry and fish replacing red meat. The third group received the same physical activity guidance plus a greener version of the Mediterranean diet, which avoided any red or processed meats and included more vegetables, fruits and nuts, as well as 3 to 4 cups daily of green tea and a high-protein shake made from the aquatic plant duckweed. After 6 months, those on the green Mediterranean diet lost 6.2 kilograms. Those on a regular Mediterranean diet lost 5.4 kilos, while those on the healthy diet lost 1.5 kilos. The green Mediterranean diet group also achieved larger falls in bad low-density cholesterol than the other groups, and they had improved blood pressure, better insulin resistance, and an important marker of inflammation, C-reactive protein, which has a key role in artery hardening. Researchers have confirmed that being obese for longer periods of time is associated with a higher risk of disease. The findings, reported in the journal PLOS Medicine, used data from 3 UK studies, which collected information on the body mass index of over 20,000 people from ages 10 to 40, as well as cardiometabolic disease risk factors such as blood pressure, cholesterol, and blood sugar measurements. They found more years of obesity was associated with worse values for all measured risk factors, especially blood sugar, which was 5% higher for those with fewer than 5 years of obesity and 20% higher for those with 20 to 30 years of obesity, compared to people with no obesity. Well, the other week we reported that scientists have discovered that platypus fur is biofluorescent. It glows in the dark under UV lights. Now, scientists with the Western Australian Museum have discovered other native mammals, including echidnas, wombats and bilbies, also have fur that glows under ultraviolet light. They join a handful of New World mammals, such as the opossum and flying squirrel, known to have biofluorescent fur. The World Health Organization is throwing away what's left of its reputation, establishing a global centre for the traditional Indian medicine, Ayurveda. The WHO's latest actions come despite Ayurveda being widely regarded by real medical practitioners as nothing more than pseudoscience. This is the latest in a growing list of controversies associated with the World Health Organization. You may recall just a year ago, the WHO helped the Chinese Communist Party cover up the lethality, high infectiousness and true extent of the COVID-19 coronavirus, which has now killed well over 1.5 million people and infected over 70 million others since first spreading out of Wuhan, China. The WHO was also slammed by scientists, as reported in the journal Nature, for supporting so-called traditional Chinese medicine, treatments first widely promoted for the masses by Mao in the 1940s. That's because they were cheaper than real science-based medicine, and they were cheaper because for the most part they didn't work. Of course, Mao himself preferred to continue using science-based medicine, proof that under communism everyone's equal, but some are a little bit more equal than others. And now the World Health Organization is giving its tick of approval to Ayurvedic treatments. Tim Mendham from Australian Skeptics says the Central Council for Research into Ayurvedic Sciences has been around for more than 50 years, but so far has been unable to scientifically confirm any core Ayurvedic theories, which continue to provide the foundations for the practice. These include the idea that blood acquires its redness from the stomach and that semen originates in bone marrow.
Ayurveda, it's an old system of alternative medicine from India. It probably does stretch back a couple of thousand years with variations on the way. It is a pretty much wide-encompassing system of treatments, cover a whole lot of different products, mainly herbal, and to treat a lot of different illnesses. And the Indian Medical Association calls it quackery. And the trouble is that even though it's been around for a couple of thousand years, there really is no evidence, no proper evidence that it works. Yes, a lot of anecdotal evidence. Obviously, nothing's going to last around 2,000 years without some people sort of claiming it's performed miracles.
Yeah, there's got to be some good in there too. Otherwise, those who support it would sort of die out. So there's got to be. It's not just a case of cleaning up the gene pool here.
The problem is that most home cures don't end up being medicine.
True.
I mean, it would be a small percentage of actual home cures that end up being sort of accepted into sort of evidence-based medicine. What happens between the home cure and the evidence-based medicine is a lot of refinement on the way, trying to find out the active ingredients and things like that.
Yes.
There's a lot of products out there that have a lot of stuff in them that doesn't work, and there might be one little element that does work and has some effect, and you have to isolate that and take it out and make it in, and sort of accentuate its properties and make it into a proper medicine. The thing about Ayurveda is it really hasn't been tested that much in a large-scale sort of medical assessment. It's just been around, and there's a lot of practitioners around. There's a lot of Chinese medicine practitioners around whose products don't necessarily do what they say they can do when they have been tested, and that when they have been analysed, a lot of Ayurvedic preparations apparently contain lead, mercury and arsenic.
Not just that they don't work, they're actually really bad for you.
They will hurt you, yes. A study in 2008, about a fifth of the US and Indian manufactured patent medicine sold through the internet was found to contain toxic levels of heavy metals. People are suggesting, yes, you need to test this stuff and you need to take it seriously. Well, take the testing seriously, and you've got to put these things to the fire to see if they really work. And the whole trouble is that anything been done so far says that in actuality, let alone sort of anecdotal, sort of it worked for my granny sort of thing, when you actually put it through a test, it doesn't work. But the thing is, there aren't a lot of tests of those done, and that's the trouble. It's just been allowed to run a bit rampant. If it's all purely based on anecdotes, someone who dies is not going to pass on the details. Someone who figures they got better for whatever reason, herbal, placebo, whatever, is going to promote the fact. So therefore, it's a situation which has just continued on for hundreds and hundreds of years
because only the
without any evidence.
Out.
Yeah, you'd say yes, there's probably elements of it that do work, but you have to find those elements and what they are. Great, research it, but research it first before you promote it.
That's Tim Mendham from Australian Skeptics. And that's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favourite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details. And if you want more SpaceTime, please check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as heaps of images, news stories, loads of videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, @SpaceTimeWithStuartGary on Instagram, through our SpaceTime YouTube channel, and on Facebook, just go to facebook.com/SpaceTime with Stuart Gary. And SpaceTime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.